All right, so today we're going to introduce you to the coolest piece of Python ever. Really? So we're going to look at how Python, so far we haven't looked at objects. Today we're going to be able to create independent objects. So we create one method to invoke an object, and then we can create multiple instances of it. So if I'm writing a game, for example, I could have a method to invoke a character, and with that method, then I invoke 12 different characters, and they all can be independent pieces inside of here. So we're going to start looking at that and how that works. So first thing, I want to make sure everybody has looked at their schedule and is enrolled in for the fall and the summer if you're going to take summer classes. So there's a few people that still haven't done that. When I look through my advisees list, and I've gotten some emails from the deans. So make sure you've gotten enrolled, talk to your advisor, and figure out what classes you need, what classes you want to take. There are some in the fall that are already full. There are some that are in the fall that are in danger of closing if we don't get students in them. So if you need a class, make sure you have looked ahead and see where we're at. So last week we had an assignment, and I'll mention that if your assignment has a grade of a 1, that's a flag for you or I, so I can say, hey, there's something wrong with that code. So for example, if for some reason you submitted code without the text file, and I have no idea how your file is supposed to run because you have multiple copies, or in the case of some people have done, they had a file that created both a text file and a pickled file for the score, I need all of those files also. So we need to look at that. There's some pieces we need to wrap up on that, and we'll do that on Thursday in terms of what people have found, what they've done. But since we extended the due date due to the holiday weekend, we'll do that on Thursday. So today I want to get into the idea of what is an object. And so we hear the term object-oriented programming. And so in theory, what object-oriented programming is, we're making these black boxes. This idea of creating a nebulous black box we're going to call an object. We create it and it can run on its own. So the way we do those is we have to write something called a class. So a class creates a method or an object. How do we create a method and what kind of attributes? And how do we tell if these objects then are public, they're private? How do we start running these objects? And why do we care about an object? What does it do for us? Well, as you've seen, being able to put things into functions should make your program more scalable. So in other words, when I start writing a program that gets larger and larger and larger, more ideas in it, the idea of functions can break it down into pieces. But what if I could even go another further step? And so I could break these into these autonomous little modules. We're going to call them objects. I can create them, and then I can invoke them even from other different programs. So what we're going to use in this chapter, and I think it's kind of an interesting way to do it, is we keep talking about something called a critter. So we're going to create an object called a critter, and we're going to create that critter then with the idea of creating them as an object. So on page 219, they look at why and what are objects. So the reality is objects are just things that we're trying to represent. So we could have people if we're creating a video game. So if I wanted to recreate the Asteroids video game, I could create each one of those as an object independently, and that gives us one way to make those controls with it. So it makes more sense once we actually sit down and start looking at it. So I think the first thing we want to do is we want to create our own critter. So a critter doesn't take that much to create. So all we really need to do, and I'm just going to open up a copy here of the idle environment. And I'm just grabbing this because I can edit it and then create a new one. So new file. And let me do this so you can see. Yes, I'm going to show my screen. So you can also see what we're doing there. So all the other things aside, and we know we've got all these other pieces we probably want to do, all I have to do to create my own class is we're going to create it with, I said we had to create a class, and class is how we create a critter, and so we're going to call him critter, and we say, well, we're creating an object. So we're going to define a piece inside of there called talk, and we'll look at what self does, because notice we're putting self in parentheses. And then we're just going to create a print statement that says, hi, I'm a critter. That's as hard as it is to create an object. Now, so you say, well, I created that. It's not going to really do anything yet. No, it's not. We have to actually assign it or create a critter somehow. So in my program, I'm going to call it crit, just to shorten it. And it's consistent with the book. So, and notice that capital letter is important because that's what I created it with. So all I'm doing is I'm creating an instance of that critter. Well, I could create something else. Remember those dot notation methods? Well, I'm just creating the crit talk method. And so that creates, so when this runs, that creates an instance of critter. And when I run crit talk, notice here I defined it as talk. So I can actually then create my own function inside of there. So nothing really fancy yet. All we've done is created our class. We assigned it. And so the reality is I could assign several of those. Now on page 222, there's a term called instantiating. And that's with a fancy name for meaning we're invoking our class. We're calling it and saying, hey, we're going to create a new object. So right now, if I ran this program, it is going to run, and it'll say, oh, I'm going to create a class named critter. I'm creating a function or a method inside of that called talk. And that talk then is this piece. So this creates it. This then would invoke that talk command. So that's pretty easy. All we've done, and if I wanted to create another copy of it, so crit 2 equals critter. Now I have two copies of it floating around. So I could create as many different copies of this as I really wanted to. And in my program, I may invoke 10 of those for whatever reason, because we're going to find out we can use them for a lot of different things. So the other new term you're going to see on page 222 is something called a constructor. So in a lot of cases, right after we invoke a new object, we use a constructor method, and we set up its initial values using that constructor. So we will show you here. So if you look on page 223, we've taken a couple of more terms. And I'm going to grab this one so I don't have to retype it all. So we've done very similar here. We created a class named critter. And notice how we do these triple quotes to tell us things inside here. So a virtual pet. Now, here's this idea of something called a constructor. So as soon as we create this class, and this is kind of a new thing that we haven't seen before. So we have these underscore items that we can use inside of objects, or most commonly we use them inside of objects and with Python. So notice we have a double underscore init, so initialize, and we call self. So in other words, it's going to initialize itself, and it says a new critter has been born. So the minute we create a new object, it's going to create a new one. So if I come down here and I added crit 3 equals critter, I'm going to make a third version. And so let's see what happens when we run this. And notice here it says a critter has been born, a critter has been born, a critter has been born. And it does that 3 times because we created 3 different objects. So we created crit 1, 2, and 3. So that is this piece here. And as soon as we create that object, we can run that piece that's inside of there. So if I need to go out and get values for it, so say I'm creating a Dungeons and Dragons style game, and I need to go out and get attributes for my character that I've just created. I can use that initialization directly to go out and get values. I don't have to just do a print statement here. We're just using it to show you what it can do. I can go out and get different values for that character immediately, so I can assign those. And so that might be one way to do it. The talk then, so this crit talk we only call twice. And so notice it only said, hi, I'm an instance twice because we didn't do crit talk 3. If I add it in there, crit3.talk, so that's this function that we created. So now it runs all 3 of those. So normally we're not going to run a print statement in there to tell you. This is just to show you that, hey, we've went out and created a copy of this. And so we could do that a dozen times. We could create 100 of those. And right now they don't have a lot of values associated with it. The only thing that they have at this point is a defined talk. But we're going to look at what other things we can do. So the constructor is kind of a handy way to go out and begin to get the values or assign things immediately after. So most of the time we create an object, we use a constructor. So on page 224 at the top, we look at that idea of that constructor. And so again, it does something a little different because we haven't seen those underscores before, but that makes sense. So we're defining an initialization routine for self. So anytime we want to do something, and so we'll look at some others. There's all kinds of different commands, underscore ones, those special methods our book calls them. So we could create multiple copies, and so each time we spin off a whole new object. Now again, ours is very simple, but again, think in terms of what if I start getting more and more complex? How do I deal with that? So the rest of the code is there, so please work through it on page 225. So attributes, if we use that constructor method, our attributes are created immediately. So we talk about these attributes, and so let's look at a few attributes and how we could create them. So what if we wanted to name our critter? So rather than just have crit1, crit2, crit3, could we create an attribute that gives each one of them a name? And we could create that programmatically. So maybe I'm creating a function for users, and so the user inputs a name, and we could create one that does that. So let's look at what happens. And let's take a look. So rather than just say crit1 equals critter, what if I try to pass a value back into it? Let's just see what happens. So I'm going to try to pass back a value troll doll. And let's see what happens. So we're going to run that. So takes one positional argument, but two were given. And so sometimes when we have these errors, we can look and see, oh, what's going on here? So this says, line 13 in module, crit1 equals critter.trolldoll, or critter enclosed trolldoll. So type error. That initialization function takes one positional argument, but two were given. Okay, so notice what it's saying. Here's our positional. We're creating a init, and it says, well, there's already a something in there, and you're trying to pass in another value. All right, so maybe we need to look a little further into this and see what we can do. So on the top of page 227, we look at something called self.name. So we can change this just a little bit. And if I come up here, and so in this, where I want to. So we're going to add this self.name as one thing we want to do. And we're going to say equals name. So in other words, we're creating an attribute piece here. We've still got our defined talk, so that program's still the same. So it's going to say, hi, who are you? And we're going to do one more thing here. So I'm going to go backwards a step. So I'm back at this level, and I'm going to define. So I'm going to define something for self, as I forget the colon. So and rep. So now I'm going to do something a little fancy. So that just spaces it out. So let's see what I've done. So I created something here. We defined a string. So rep equals critter object, and then we added plus name, and then we're pulling in the self name. So that self name is what we created down here and pushed in. So now let's see if it runs. So let's run. So invalid syntax. What did I do? Something on. Something on. Oh. What am I doing there? I don't need that. Chunk. Okay. Fix my typing error here. And we still have an error. So let's see what's going on. We're still saying that we have a positional error. In other words, we're still trying to give it 2 pieces instead of 1. So if I look up here, well, the other piece we need to pass in then is name. So we're taking in 2 things. So it takes in itself and it takes in this value here. So run. So now we fixed that error. Oh, but now it says, hey, you're missing one of your required arguments. So now it says, hey, you are taking in 2 items, but you're missing one. So let's take a look at what we're assigning here then. So if I look down here, I say I've got crit 1 equals crit, so we're assigning it a value of troll doll, because, you know, everybody needs a troll doll. We've also assigned it, so self.name equals name, okay, and define this string, except we need one more item. Notice we didn't have a return on there, so nothing in this could pass back. So let's see if that fixes our issue. No. So what are we doing differently in here that we're not getting in that name argument? So apparently we're getting self. Well, let's see what happens. We can experiment to try to see what happens. So let's take out. So I can try that, but that doesn't change anything. So it still needs that self in there. So let's take a look at the code that they provided on 226 and 225. So it's split out over 2 different pages. So, and I'm going to cheat and grab another copy of it. And let's take a look at what the differences are. So here's the one we've been playing with. Wrong one. No, too many copies of things open. So we defined with a constructor self and name. Now we're going to say print a new critter. Self.name equals name. So in other words, when I invoke the object using the .name convention, I'm going to get past the name back out of there. So Let's run this one and see what the difference is. So this one says a new critter's been born. So in other words, that constructor ran. And then it invoked the, move it over here. And then it invoked the talk. It said a new critter's been born, so it ran this piece, which caused it to initiate a new object. So it created, and it says, hi, I'm Poochie, hi, I'm Randolph. So in other words, we have two separate objects with different values inside of them. So that one. Cut some of these down here. I got too many shells open here. Okay, so let's take a look at this one compared to our original. So we created a class object. We defined it. We gave it a self name. And we're going to say a new critter's been born. So in other words, this runs whenever we call a new function. This allows us to create a name for it. So it'll print out its own name. So critter object name plus self name. So, and then we have this where it can say, hi, I'm blank self name. So let's see what that does. So creates it, calls the talk method, which is this. Says, hi, I'm Poochie, I'm whatever I pass in there. And do we have to use, so could that be an input from a user? Yeah. So we could create input from a user. Now we could print it though. So this says print crit1. So we're going to print whatever we have in here. And so we'll see what that does. We'll look at its output. And then we're directly using printing the name. So what is the difference in there when I run those? So let's run that. So if I run that, printing crit1 says, well, we're going to create a critter object. So it prints this. Name, it's Poochie. So it prints this piece here when I try to access it directly. Interesting. But if I access it with crit1.name, notice it only prints the Poochie part. So directly accessing it, I only get Poochie. So we're assigning a value to Poochie that's accessible internally and externally at this point. So if I had changed this one to Mark, run, yes. So now it's going to say, a new critter's born, hi, I'm Mark. Now we could create these then programmatically and create a ton of objects with independent variables. So we created an object, they're all the same, and they exist. So there's the difference between that and a function. I've now created this, and it stores those values. It maintains that value, that attribute, internally. So we can create them, aside from my typing errors. And we can create these objects then. So we only created this piece of code. So in other words, we created the code to create it, and internally Python stores that information. So if I wanted to print crit2.name, because that's a value we have inside of there, notice it'll say it. Directly accessing crit1 name is Mark, but I added a second one in there for crit2 name, and we can print that out directly. And so it's maintaining those. And if I created a third character, so we'll call that crit3, and we'll call him Santa. I said, well, I don't know if Santa really exists. Print crit3 name. I'm going to run this module. And notice it created a new critter, a new critter, a new critter. And then down here when I directly accessed its name, it says, hey, I'm Santa. And so we could use that and we can create those. So if I think of a video game, I'm creating all these different pieces that I could get to directly. So on page 228, there's a little tip and a trick. So it talks about how we printed that object, and that we did that by creating a string method. So we did this. Oops, I look at the wrong one here. So we created our own string method. Well, we may not print it, but it's not a bad idea to put it in there for error checking. So we could create one very similar to this in all of our objects, and we could use it for error checking, even if we don't call it in the program directly. That way, if we run into an issue, I can just put in a print very quickly to see what's going on. So that's well and good. So we can create all these objects, and we could go on and on and on. We could create crit4, big elf, and it's going to run and create another one called big elf. So we could have almost as many of these as we wanted. I mean, there are some limits, but it generally crit4.talk. We can have him introduce himself. And so now we've got 4 of these running around, and they've all got Mark, Randolph, Santa, I'm Big Elf, or Elf, I guess. So we could have all these characters. They've got all their own individual attributes. Now, right now, we haven't put a whole lot in there. They've got a name. But you can see how we could start adding then other items to those pretty easily. So we could add in age and height and weight, or all different kinds of things about these pets. So it's sometimes handy, though, to think about how do I create something that I can pass to all kinds of these objects. So in other words, we have 3 or 4 objects, and rather than pass it to just one, I want to create it. So one way to think about this is, think of these as like a blueprint or a plan for creating my objects. So this is my plan. My objects I create are internal, and they run individually. So I can create as many of these as I want, but maybe I want to keep track of how many critters I have. So we've created this class, but I don't have any way yet to create and look at how do I control those individually. So we're going to have something called a class attribute. So you have an attributes internally to each object, and you can also create an attribute that is available to the entire bunch. So if I look on page 230, we're creating another version of this critters. So in this particular one, we're going to add something called a static method. Okay. So a static method is something that we can control the entire class with rather than just an individual attribute. So if I wanted to know how many objects there are, because right now, how many objects have I made? 4. So we're going to close that out, close this out. So we're going to look at the code as we march right along here. We're going to look at classy critter. And so classy critter shows us this idea of creating a static method. So it doesn't look a lot different. So we have our class again. We're creating a critter.object. But notice up here at the very beginning, we set something called total equals 0. Okay. And then we have our status. So we created a method inside of there called status. But notice what I did here. Notice it's got the ampersand in front of it. And then we're going to have a function. So anytime I see init, I know that's my constructor. So that runs directly when this object is created. So it does a couple of things. Remember, very similar thing, takes in 2 attributes. Self.name equals name, so we can access that directly. And then look here, critter.total. So in other words, critter.total adds 1 every time one's created. So this maybe will give us a way we can run. So it creates 3 critters, 1, 2, 3, and then can tell us how many there are. So in other words, it runs this method called status. But we can also access that directly at crit total. But wait a minute. Notice how I did that. So let's take a look at this real quick. So notice it says critter1.total. So let's take a look at something interesting. So is it creating a value that's stored identical in each one? Well, let's find out. So we know we ran 3 instances. So we created 3 critters. So a critter's been born, been born, been born. So we created 3. Total number of critters is 3. So in other words, when I access critter.total, so I access the entire class, that gives me 3. But notice that that value is still in each individual one also. So if I do a crit1.2.3, I get 3, 3, and 3. So not only is it storing it as a class, it's also storing that individually. So I could use this to pass things to every copy of my object. So maybe these objects are characters in a Dungeons and Dragons game. And every time we want them to start out with 18 lives, we could pass that in doing a very similar method. So in other words, it's a way that we create a class attribute, so it's available class-wide. So there is something a little unique about these though. So if I tried to change that, so I wanted to change crit3.total, I can't have crit1 and crit3 values different. It's class-wide. The only way I can change that value legally is through going back to the class and assigning it a value. So if I need to keep track of these, so this might be a good way. Maybe there's bad guys and good guys. I can keep track of how many bad guys they are so that I know the game ends when all of the bad guys are dead. So in other words, I'm looking at that critter.total when it's equal to 0. So the other weird thing, so because I created this as a class attribute, I can actually utilize it even before a class is called. So normally, if I tried to access crit1 and it hadn't been created yet, I'd get an error. So in fact, we can do that by going here. And so sometimes we can create errors. So notice I didn't create critter1, and so it's going to crash and say, hey, crit1 isn't defined when I tried to access this. So let's run it again. Notice and it says, oh, 2 critters. How many critters? And we could access that class attribute. So I could even do that if I got rid of all of those. So if I went down. So now we're not calling a single. We're not creating anything. No objects are created. But yet, I can access it. And it says 0. If I would have tried it through an object, I would have got a big fat 0 nest egg. Oh my goodness, what are you doing? Why are you trying to do that? Don't do that method. So this idea of these classes just gives us a way to create objects that have values that stay with them. We can modify values in total. So in other words, we could create a class that had a value for both an object and the class. And we can pass those values out pretty easily. So let me take those back out of there. Chunk. So now our program's back. So this doesn't look that different than what we've done with functions, except that now we can access these objects completely independently, and they have a little bit of persistence. In other words, they store those values internally, just a little bit better than we do. So this is where, in that very first thing in this thing called a constructor, that adds a value. And we can do all kinds of things because this is going to run anytime this runs. So as soon as we create an object, it also does a really good job of updating then so there's nothing magic about these, and you're going to see if we look at a far more complicated program, they use a lot of these classes. So if I go in and just because we have access to it, and so I look at Astro Crash 8. So I grab the program. It'd be handy if I did that. So this program creates something very similar to Asteroids, the video game. So if you look back and you see it, notice here we created a class. We created a class. We created a class. Another class. And so let's look at a couple of them. We don't know this whole program yet, but we can certainly look at it. So class wrapper. So this says, well, that's a sprite that wraps around the screen. So in other words, it gives us some border. Here we have class asteroid. And notice we have different models of those asteroids. They define, so in other words, it has a constructor. It also has a function called die. So in other words, we can get rid of classes. So we can not only create them, but we can destroy classes as we need to. Here's one called ship, the player ship. And so it's got a lot of different details on it. Class missile. So the missile that the player launches. An explosion class, game class. And then down here, we have our functions again. So here we define main, and we're going to essentially call a function called game to begin our program. But that's where we're kind of headed to, this idea of these classes and objects being independent, autonomous little units we can create, and we can set them free. So once we create these objects, we can scale them out very, very easily. So Python doesn't care if we had one object or a dozen objects, and we can prove that. We can create a dozen of these if we wanted to. Now, making sure, of course, we create a new name for each one. And we can even do this programmatically. We'll call you 10, 11, 12, 13, 14, 16, 17. So there, I'm going to make 17 critters, I think. Run module. So it says critters been born, been born, been born, been born. Total number of critters is 16. Whoa, wait a minute. Didn't I say I have 17? Well, notice I made a little typing error here. Oh, I forgot one. Okay. So I need one more because I wanted 17 of those. That should be critter 9. I skipped a step. So now I'll run it again. And so now it runs and says, hey, you've made 17 of those. And I could pull that value from any of these. So let's see what critter 17 says and what 10 says. They're all going to have the same value by using that. So 17, 17, 17. It's stored essentially and available for any piece of that internally. So we covered a lot of material. On Thursday, we're going to look at private attributes and private methods. So one of the things right now, notice these all seem public. So in other words, I can access this from anywhere. Well, maybe we want to create objects that can't pass information back and forth as easily. So I know I've harped from the beginning of working with Python that you can't just look at the code in the book and learn how to do it. You have to sit down and try it. Well, this is the most conceptually difficult, but in reality, once you learn and you think about objects and what happens. So sit down and make an object, make a constructor for it, make sure it can run. And I could put anything in there. I could have it run, you know, I could make it do anything in that initialization. And so a lot of times that's where we pull information. We go out and we look at, hey, here's an object, it needs these attributes, how do we fill those attributes? And they don't have to be the same. I could have 17 copies of Critter, each one with its own name. Each one with its own, if I wanted to add height, weight. Maybe I'm creating this for tagging purposes for the Fish and Game Commission. So I created a class named Fish. And all that Fish does is store that information about the different types. Now, what happens as soon as this program dies? So it ends. Well, all that information is lost. So then we also have the piece last week where we looked at how do I store things permanently. And so if I combine these, so in other words, I create a file that what my constructor really does is go back out to that characters file and pulls in all that information. That's a pretty handy thing to do. And that's what a lot of games do is they'll create classes, and then inside that constructor, and normally our constructor is silent. Very rarely are we going to print anything or show anything happening with that constructor. On the other hand, when I'm writing these, is it a handy thing to do to have these in as test cases? So, yep, I created. There I didn't create enough. And so it's a great tool to use to be able to test and analyze our issues. So the reality is we have 2 programs left to build and a final, and that's it. The end is near. And so if you look ahead, so if I grab my book and I'm looking ahead at it, we're looking at Chapter 8, which is object-oriented projects. And so we're going to look at a lot of detail about object-oriented. And then we're going to utilize them. So now this week you're going to modify a Critter program. And then next week we're already going to start to look at how do I do a blackjack game, and how do I create things like a card and objects with cards. And so we're going to look at that. The rest of the book, though, there's a lot of information that really is pretty handy. So we're not, unfortunately, going to get to chapters 10, 11, and 12 in here. And the reality is this is just a beginning to Python. So I will recommend, if you've gotten a love for this, the author has a second book called More Python Programming. And what I like about this is it starts out with all this idea of games, which we all like to play games. So at the end of this chapter, so chapter 10 looks at GUI design, which we don't touch yet. In other words, how do we do that graphical interface? Chapter 11 starts talking about graphics, so we can create graphics. And by chapter 12, you're able to construct your own asteroid game and something very similar to it. So Python progresses pretty rapidly. So once you get these basic skills, so now that we know how to create a method, we know how to create a function, we now know what an object is, we can go out and build almost anything we want to at this point. Is it going to be easy? No, there's going to be some hurdles and trips. The reality is most of the time it's not hurdles in the actual coding, it's hurdles in how do I lay it out, how do I design it, how do I make it do what I want it to do. The syntax piece is easy. We can always go back and fix that. That logical piece that we spent the first 8 weeks on, how do I create that program logically, how do I make it flow, is really quite a bit harder. All right, so we'll let you get out of here today. And then on Thursday, so make sure you've turned in your assignments if you haven't. We did give you a 2-day extension for the holiday weekend since class wasn't even in session yesterday. So turn those assignments in, look for that flag. So I know there's a couple of them that have a weird flag for whatever reason. Maybe it didn't finish uploading in one case, I think. And then on Thursday, we'll talk again about objects. We'll look at private versus global methods. In other words, how do we keep all these objects private? Think about that in terms of a game cheat. If you could design a Dungeons & Dragons game and access everybody else's character information all the time. So if I think about it that way. So go through and try to create some objects. You don't have to call them critter, you can call them whatever, but these are some good starting points to start looking at how do I create objects. Because that is one of the things that we do with modern programming languages. Almost all of the newer languages are what we consider object-orientated. In other words, we create these objects and we have kind of our data dictionary. We know what's in that object and we set it free. And so we may create an object for people, and there's only some things we use in it. So if I created a program for student information systems, I might have things I don't use and things I do use inside of that. So I can create an object that will encompass students, faculty, staff, visitors, and only when that is created do I create a visitor 1, visitor 2, visitor 12, or student 37. All right, so we'll talk about your homework on Thursday, look at a couple of samples, go through and really work at these. This is, to me, this is kind of when we start getting fun, because we're starting to create these independently assignable pieces. And so what we would do before in a very large program, we could create a program that doesn't have objects, and there's a lot of software that doesn't. But once you see how powerful an object is when we start working with things, it literally becomes, once we create it, that black box. We feed information out, we create objects, we kill off objects, and they can run